This decimal point system, which we have already learned from our childhood, how we represent any number. So in decimal point system, we have two popular systems which our computer also uses. We do use it for our manual computation, as well as the computers also use the same system unless until we get a hardware which supports quantum computing. But so far, what systems you and we have, they follow this kind of number system. The first one is fixed point system. इस पे थोड़ा ध्यान दीजिएगा. This is important to understand. Fixed point system. What is fixed point system? Fixed point system में ये है कि जैसे if I needed to store 1/2, then it is 0.5. Okay, or 1/3. So its decimal representation is 0.3333, and it will continue like this. तो एक तो तरीका ये है कि हम किसी एक पॉइंट पे रोक दे. जैसे पहला एग्जांपल, द फर्स्ट एग्जांपल 1/2, it has only one decimal place, so it has no issue, it can be stored in the computer easily. But when we are about to store this 1/3, then after certain number of decimal places, depending on which type of system you are using, line is whenever we need to store this 1/3, we need to chop this particular decimal representation after few decimal places. Okay, so when you fix those decimal places, for instance, suppose I fix that I am going to store it up to 3 decimal places. Okay, so this has its standard notation. This is called 3D. So this means that we are wishing to store this 1/3 up to 3 decimal places. So what will happen? This 1/3 will eventually have the value 0.333, which has two aspects. One of them is it is not exactly equal to 1/3. So this is one of the limitation of this fixed point system. And another aspect is, suppose at any point of time, if I am arriving that we have fixed this 3D for the entire computation, means एक कैलकुलेशन का सिस्टम हमने स्टार्ट किया जहां पे ये फिक्स कर दिया है कि कोई भी नंबर आएगा उसको हम 3 डेसिमल प्लेसेस तक ही यूज करेंगे. तो अगर किसी पॉइंट ऑफ टाइम पे, एट एनी पॉइंट ऑफ टाइम, अगर हमें ये वैल्यू मिल जाती है 1/10,000, so what will happen? And we need to use only 3 decimal places. So this will, your computer will assume its value 0. Okay, so that may not be very much helping when we are doing some scientific computation. So this is what we should understand by fixed point system, where we fix the decimal points and we proceed like this. So it is a system जिसको कि use किया जा सकता है. ये इसकी limitations है. Okay, it is not popular and not widely used because of the obvious reasons. Because if you are doing some precise computation, then it won't be feasible to use, especially in the scientific computation. The another system which is being used in the scientific computation is the floating point system. This what I'm saying, floating point system. Okay, so what is floating point system? It is a system where we denote the same number in a scientific notation. Okay, in a scientific notation you have already used it. I only need to give you an example, you will connect it easily. Suppose if I write a number like this 6.247 into 10 to the power 7. Okay, so this is the number representation. We call this particular system as a floating point system, or this particular architecture as a floating point system. It has various parts. इस पार्ट के अपने अलग मतलब हैं, इस 7 का अपना अलग मतलब है, and this 10 has a separate meaning. But this is very much useful, and our current computer systems widely uses this particular type of floating point system. Basically, when we do simulation or computation, this is the widely accepted way of doing computation. इस फ्लोटिंग पॉइंट सिस्टम को हम अच्छे से समझ लेते हैं. So floating point, before understanding this floating point system, we must understand what is floating point number. Okay, floating point number. Suppose I am declaring that A is a floating point number. So we represent it like this: plus minus m into 10 to the power n. Okay, plus minus m into 10 to the power n. This is how we represent any floating point number. This was just an example. ये इसका एक उदाहरण है. That's all. इसमें m has a very specific nature. M is greater than or equal to 0.1 and less than 1. So obviously it is a positive number, and I'm just talking about m. ये plus minus इसके पहले. Okay, so m is ranging between 0.1 to 1. This is less than 1, not equal to 1. Just be careful. And this m is called as mantissa. Okay, and this n is called as exponent. Again, I'm repeating, this m is called as mantissa and n is called as exponent. अब थोड़ा सा इस m पे हम बात करते हैं. ओके, m को अगर हम इस तरीके से रिप्रेजेंट करें, बिकॉज m हैज अ डेसिमल पॉइंट नोटेशन, और इसको हमने बोल रखा है mantissa. So if I write in a more elaborate form, 0 point, suppose this is first digit, this is second digit. In this way, it will keep on going. Okay, अभी हम स्टोर करने की बात नहीं कर रहे हैं. अभी हमारा ब्रेन वर्क कर रहा है जिसकी कैपेसिटी अनलिमिटेड है, तो हमें विजुलाइज करने में कोई दुविधा या दिक्कत नहीं है. डीके एंड सो ऑन. ओके, when this number will be transferred to any computer or system, then it will have a different structure. वो हम थोड़ी देर में अभी समझेंगे. But this is how this m will look like. Okay, इसको हम यहाँ जीरो की जगह पे कोई नॉन जीरो नंबर भी लिख सकते हैं, बट उसका कोई ज्यादा सिग्निफिकेंस होगा नहीं, बिकॉज यहाँ से हमने ऑलरेडी देख लिया कि यही सिग्निफिकेंट डिजिट्स हैं, चाहे D1 पॉइंट लिखें या 0.D1 लिखें. सो दिस इज गोइंग टू बी द स्टैंडर्ड फ्रेमवर्क फॉर m. ओके, या नहीं है तो हम बना सकते हैं, और यहाँ पे अगर पहला जीरो अगर नॉन जीरो है तो उससे भी कोई समस्या नहीं. ओके, but this is how in general this m will look like, and this is what we are calling as mantissa. mantissa, ये लॉगरिथम वाला mantissa नहीं है, आप उससे कंफ्यूज मत होइएगा, इसका उसका कोई रिलेशन नहीं. ओके, mantissa. So this is mantissa. अगर कोई नंबर आपके पास होगा, ये तो m की बात हो गई, एंड वी आर डिस्कसिंग दिस फ्लोटिंग पॉइंट नंबर, तो a कैसे रिप्रेजेंट होगा? a रिप्रेजेंट होगा आपका इस तरीके से, प्लस माइनस कोई भी साइन हो सकता है, 0.D1, D2, DK. This is for understanding. Okay, it will keep on going, but in reality it cannot go because we have limited space when we are doing things on computer. Into 10 to the power n. अब यहाँ पे जो 10 है ये एक पॉपुलर एंट्री है, बट इट इज नॉट रिस्ट्रिक्टेड टू 10. ठीक है, दूसरा पॉपुलर जो एंट्री है वो है ई. ई, दैट इरेशनल नंबर ई. बट आप 2 से 10 के बीच की कोई भी संख्या ले सकते हैं इसके लिए. यू कैन ऑप्ट एनी नंबर बिटवीन 2 एंड 10 which will work here as a base. Okay, but popular base जो है वो 10 और e है when we are doing real number computations. बाइनरी में जाएंगे तो 2 का बेस आप ले सकते हैं, बट we will use 10 क्योंकि यही कंप्यूटेशन में पॉपुलरली यूज होता है. तो इस ये पोर्शन मैंटिसा हो गया और इसको हमने बोल दिया ये एक्सपोनेंट है. Okay, so there should not be any confusion in the floating point system कि क्या पोर्शन उसका मैंटिसा है और क्या पोर्शन उसका एक्सपोनेंट है. दिस इज m मैंटिसा एंड दिस इज एक्सपोनेंट.